the triangle mid-segment theorem. Sorry. Put your head up. Get your pencil out. Put your name on your notes, please. As always, these are points turning in on the day of the test. That's it? You have your name on your notes? Okay, what we found was a special relationship between this mid-segment, up here please, L to N is a mid-segment. A mid-segment is made by joining midpoints. Remember how we found L was a midpoint and N was a midpoint? When you connect midpoints, you get a mid-segment. Once again, what was the relationship from this mid-segment to the base of the triangle? We've answered this twice already. This should be the third time. What's the relationship of this mid-segment to the base of the triangle? It's half the length. That's the mid-segment theorem. And the segment joins the midpoints, L to N. The two sides of the triangle, then the segment is, we get two things actually. It's parallel. So these two are parallel, and the third side is half as long. So draw a picture really quick of a triangle. Find the midpoint on the left side and the right side. And connect them. That's what we did. This was L and N. C was on top, A and B were on the bottom. So this segment should be parallel now to the base, which is the third side. How would we notate on a drawing that they're parallel? How do we show on the diagram that these are parallel? Yeah, little arrows. So this is parallel to this. So now we have LN is parallel to AB. Isaiah, you need to look this way. And please put your bag on the ground. And we have a second thing that happens. We now know that LN is what to AB? Not congruent. Definitely not congruent. Half. So if we times AB by half, we'd have the length of LN. Okay? The math we're doing today really is pretty easy if you understand the theorem. So that mid-segment, two things you need to know. It's parallel to the base across from it, and it is half the length of the base. Okay? So on this first part, example 1, what are the three pairs of parallel segments? Do we have any midpoints on a triangle? Okay, where's the midpoint, Bella? On as a midpoint. How do we actually know that those are in fact midpoints? Alright, this table, you all need to turn this out facing forward, please. Yeah, so the other two, you need to turn your desk out facing forward. So you look at me and not each other. Turn your desk around facing forward. Thank you. Keep going, Isaiah. All the way forward. That's much better. Thank you. How do we actually know that R and S are midpoints? They look like they're in the middle, but how do we know they're actually in the exact middle? Yeah, those tick marks. One tick mark means those are congruent, right? So DR is congruent to RE, so that has to be the midpoint. And we have three tick marks here. That tells me S is in fact a midpoint. So if we join midpoints, what's this line called? We join midpoints, it's called a mid-segment. Mid-segment. Okay? Now because of the theorem, R is looking for parallel segments. Has to be parallel to Brian, look this way. RS has to be parallel to what? DF. You can call it DF, but short is DF. Okay? RS is parallel to DF. And we can mark that with one arrow and one arrow. Because of our segment, any mid-segment that's joining two midpoints in a triangle is parallel to the third side. Brian, did you write that down and do the marking? Put your pencil, Brian. So because we have a triangle, we should actually have three sets of parallel sides, parallel lengths. Can you find another mid-segment? There's another mid-segment, Colby. I need two letters to know what the bottom is that you're talking about. That's one letter. That's a midpoint. Mid-segment has two endpoints. T to, what's another midpoint? T, we know it's a midpoint because of the double. T to, which one do you want to get? To what? To S, because S is a midpoint. If we connect those, that's another mid-segment. Just like we rotate our triangle, TS steps in. Because of the theorem connecting midpoints, we get a mid-segment. It has to be parallel to what side, Stetson? No. Yeah. TS, and then do a marking, and then do two arrows. TS is parallel now to the opposite side, DE. So write that down. TS is parallel to DE. Make sure you have a segment bar above them. There should be one more. Because it's a triangle, we would expect three pairs. So that's the third pair. RT, where's RT? And R and T actually both, are they both midpoints? That's the only way that they're in one. So we have R and T are midpoints. So when we join them, we get a mid-segment. Okay, and then RT is parallel to what side? EF, yep. And so we mark that with 1, 2, 3, so it's one, or three arrows, I guess. RT is parallel to EF. Okay, they ask you to just list the three pairs of parallel segments. That's how you would do it. Find the midpoints, the mid-segment that joins the two. Okay, and the side across from it is going to be parallel. Okay, and the next problem, example 2, down below. Again, it wants the three pairs of parallel segments. Triangle XYZ. Anyone see the triangle? So what can we do to help us figure out? Maybe draw it and label XYZ. You can draw any triangle you want, just change things up. I'm going to draw a different triangle, same kind. Anyway, X, Y, Z. A is the midpoint of what? X, Y. So make sure you label it exactly how they say. A, find the middle there. Eyeball where the middle is and put A. B is the midpoint of which side? Y and Z. So eyeball where the middle is and label it B. Isaiah, do you have any sign paper? C is the midpoint of C and X. So they tell you all of that. So find the middle and label it C. Okay? What are the three pairs of parallel segments? Jasmine, if you can tell me one pair. Okay, hold on. CB, right here. That's called what again if we join the midpoints? What's the vocabulary? If we join the midpoints, we get a segment. So CB is parallel to what? The XY. And you want that with the arrow. Okay. Tyson, can you give me another pair, please? AB, and we get a different color. AB, it was only works when those are midpoints, and we were told that they're midpoints, so it would work. AB is parallel to what, Tyson? What's the opposite side of a triangle? XZ, yep. Okay, one more. Omar, can you get, actually let's mark that really quick. Double arrow. Omar, can you get me the last one, please? AC, look how it makes like a mini triangle inside. AC, Omar, is parallel to what side? The opposite side of the triangle, and they should actually look parallel. Now, BC goes this way. YZ. See how they only look parallel? That's the only one that doesn't intersect, is YZ. Because parallel lines won't ever intersect, right? So it would be the side that doesn't intersect with your segment. Okay? That's listing the pairs of parallel sides. Any questions on those? Now we're going to use the other part of the theorem. Again, what was the relationship of Ln to the base of the triangle here? Last time we've answered this. Ln is what relationship to the base, AB? Half. Parallel and half. And the second part of the theorem is that it's half the length. So, our next problem, example 3, we have another triangle and we have lengths. Instead of listing the segments, we're going to find the missing lengths. It tells you T, U, and V are midpoints. So these are midpoints. T, B, and U are midpoints. We're allowed to use the mid-segment theorem. So connecting them creates mid-segments. What is the length of, we'll start with just one. TU. The answer in the air when you know the length of TU. What else the answer in the air? What is the length of TU? Well, you can do digits, right? That's what we have. 20. Anyone tell us why we got 20? Is it just half of something? What's its parallel side? The 40, SR, they're parallel. And the mid-segment is half. It tells you the wrong side is 40, so TU has to be 20. Yeah? Because the 50 goes to a different mid-segment. Because they have to be parallel. Those relationships for the parallel sides. And these two sides are the parallel sides. Later we'll use 50 for a different one. So the measurement of TU is 20. Now it wants a different one, UB. Oh, that's more than I wanted. Okay, UB is right here. In order to find its measurement, you really have to identify the parallel side. Okay, Brianna, what's the parallel side to UB? Yep, QS. Okay, so now that we know the parallel side, you guys should be able to show me if you ask, how long is UB? Good, Austin. Good. Good. Justin, you got it in the air? How long is UB? Aria? AJ? Juan? AJ? Cover your eyes, please. because you just do half, right? So measurement, UB is 25. One more, measurement of QR. Find the measurement of QR. Where's Q? There's Q and R. The screen size. Ooh, we want the long side this time. So there's the airplane, but you know the measurement of Q. We might not have enough things for that, huh? What's it going to be? So this time, you know the segment is 30, so the long side has to be double, 60. Okay? The math isn't really that difficult, as long as you understand the theorem. Yeah. Okay, so I'd like you to do this one on your own, but before I let you try it, let's make sure you notate the information they give you. In the figure, A, B, and 6, so where should I put the number 6 on my figure? In between A and D. DE is 7.5. So on 7, DE you should put 7.5. Okay, I'd like you to do this one by yourself. Find the measurement of DC and hold it up in the air when you know it. Find the measurement of DC and hold it up in the air, please, when you know it. Good. DC. How long is the segment DC? Good. No, that's the second one. Good. Brian, where's DC on the picture? Okay, are there any markings on DC?
Yeah, there's 2 lines.
Is there another segment that also has 2 lines, which means it's congruent? Do we know how long ED is? So DC must also be, yeah, these 2 are congruent. So they're both 6, which means D is actually a midpoint. So DC is 6. Okay, please find AC and hold that up in the air. The length of AC. AJ, I need you to participate, please. Tommy, get up in the air. What's the length of AC? Good. Good. Isaiah Cooper. It's not just 2. No. Good. Isaiah, there's numbers on AC. 6 and 6 makes how much? 6 plus 6. Oh, you're waiting a little bit. Okay, let's find EF. Now that we know this whole side is 12, look at where EF is. Does anyone have a vocabulary word for what type of segment EF is? Is there a vocabulary word for what type of segment EF is? Nope, it's a segment. Mid-segment, which is connecting midpoints. So we have a mid-segment theorem. E to F. Hold up in the air, please, the length of E to F. Good. Noah? E to F. Thank you, AJ. Yep, it is 6. If this side is 12, the mid-segment is half. So that would be 6. Last one. Measure A to B. Hold that one up in the air, please. A to B. Do you know how we get it? What? I can't hear you. Who can explain how we get 15? Jeff? DE is half. And how long is DE? So DE is 7.5. So this side is double. Isaiah Cooper, what's double 7.5? 15. That's how we get 15. Okay, flip it over, please. Okay, story problem. A geologist wants to determine the distance AB across the sinkhole. Before you read any further, make sure you take that information and visualize where it's on the picture. Where's AB on the picture? Across the sinkhole. That's what we're trying to find. Choosing point E. Isaiah Cooper. Choosing point E. Where's point E is there on the picture? On the left. So every time it gives you information, make sure you know where it is on the picture. Choosing point E outside the sinkhole, she finds the distances. AE, ooh, that kind of creates a triangle, yeah? And E to B. She also finds the midpoints. So we know we can use the midpoint theorem. And the segments tell you that those are congruent, which means that D and C are actually midpoints. What is the distance across the sinkhole? No, 46 is on the edge of the sinkhole. What is the distance across the sinkhole? Yeah, 92. How do we get 92? What? Double. 46 is just from here to here, but we want all the way across. So that's 92. So when I answer it, right answer up, please. We did right. It's 92 what? Feet across what? The sinkhole. Make sure you explain what your answer is on the story column. Okay, that's the end of the mid-segment theorem. Any questions on that? The math is pretty easy as long as you identify that you can use the mid-segment theorem. Okay, perpendicular bisection theorem. Who can tell me what perpendicular means? Okay, the intersect, yes, but what angle? Fine. 90 degrees, yep, the intersect is a 90-degree angle. What does bisector mean? Okay. What does a bisector do? It has something to do with a half. And what? Kind of. It goes in between. It cuts it in half. Intersecting, it cuts it in half. It goes all the way through. Okay, so a perpendicular bisector theorem is if a point is on the perpendicular bisector of a segment, if a point is on the perpendicular bisector of a segment, then it is equidistant. Then it is equidistant from the endpoints of the segment. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So I'll draw a picture so you understand what that means. So give me 2 letters, please. What? So, as long as they're not L and O, I will take them. So, S and M. Okay, that's our segment. Where does the bisector cut through? In the middle. Okay, and it's a special kind of bisector. It's a perpendicular bisector. So this theorem is saying if we have any point that's perpendicular bisector. Maybe this one right here. And I loosen up this. And I connected it to the end point. That length will be congruent to this length connecting it to this end point. And we can prove that with side angle side anyway. They share the same side, right? Yes. They share the same side. They're both 90-degree angles. And we know bisector means the base is connected to this base. So side angle side, those are considered triangles. So this hypotenuse is connected to that hypotenuse. But if I take the difference, like way up here, as long as it's on my perpendicular bisector, and connect it down to S, and connect it over to M, this length would be congruent to this length. That's what the term is saying. Okay, no matter what point you take on a perpendicular bisector, it creates congruent lengths connecting you down to the endpoints of the segment. The converse is complete reverse of this. This one started with, given the perpendicular bisector of a segment, we get the point is equidistant from the endpoints. I didn't say that very well. So the converse is, if the point is equidistant, then we have a perpendicular bisector. Converse means reverse the order. If a point is equidistant from the endpoints of a segment, then it is a perpendicular bisector of that segment. If a point is equidistant from the endpoints of a segment, then it is a perpendicular bisector of a segment. So it's basically the same thing, and they just reverse the order of the phrases. That's what the converse is. And what's an angular bisector? What? It's not just a point, though. It's a line that cuts through where on the angle? Cuts it in half, right through the middle. Okay, so the same idea will apply. If, oops, let me get to the right page. Make sure I read it correctly. If a point is on the bisector of an angle, this is the last thing I'm going to write down. So converse will just say and we won't write it down. If a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. Then the point is equidistant from the sides of the angle. The point is on the angle bisector, then the point is equidistant from the sides of the angles. The converse is just reversing that. If we have a point equidistant from the sides of the angles, then we have an angle bisector. But we're not going to write that one because you guys are dying over there. So draw an angle. Where does the bisector go, Colby? In the middle. Let's cut through the middle. length on this angle bisector right here has to be equidistant from both the upper ray of the angle and the lower ray of the angle. Advance it up, please. What's the shortest way to get to the angle? Should I go left diagonally? Should I go right diagonally? Or should I go straight to it? What's the shortest distance to get to that side of the angle? So, what do you say? Straight to it. And it creates a special intersection. What type of intersection is that? So 90 degrees, that's the shortest distance. So both of these lengths would be congruent by the angle bisector theorem. But if we picked a point way out here on the angle bisector, Isaiah, it's this way. That length to the angle would be congruent to this length, to the other side of the angle. Angle bisector theorem. Each point on the angle bisector is equidistant from the angle. Okay, the column versus the versus the order of those. What is the length of A to B? There is A to B on the triangle. Okay? Can we just say our answer is 4x? That's the length. Call it good? No. No. Let's define x. What type of triangle? Well, what do we have on our triangle? There's 90 degree angle inside the triangle, which means this segment BD is what type of a segment? And a special type of bisector. It's a what? I'm looking for a P word. Perpendicular bisector. So we have a perpendicular bisector. This is compared to this because it's a bisector. And we have a theorem about perpendicular bisectors. Perpendicular bisector theorem, we just went over, says you can pick any point on the perpendicular bisector, specifically in this case, point B, and this side has to be what to this side? Equal. This has to be congruent to this. So if we wanted to find x, how would we find x if we know that those two sides have to be congruent? Good. Set them equal 4x equal to 6x minus 10. Once you have x, would you please stand up? You have x, please stand up. Come on. Go for it. Go. Go for it. You stand up. Once you have x, please stand up. Good. Okay, so we're going to set those two sides equal, right? 4x equals 6x minus 10, and use inverse operations to find x. Good. Okay. Good. So show the work, how you do that. Okay, how the work? You write 4x equals 6x minus 10, and move the x's over. Good. Good. Yeah. Okay, C. So I solve for x. Fine, this is over here. Get off the desk. And then look over him. Fine. We don't need the commentary. Now, I'm doing the 6x over here. So we have negative 2x equals negative 10. Now what? Colby? So what? Negative 2. So x is 5, but that's not our answer. Just like in our last test, you have to be careful with fractions. Sometimes it says by the value of x, sometimes it says by the measurement. Marianne, once we have this x, how do we find the length of AB? Plug it in. Good. So if AB is 4 times x, the measurement of AB has to be 4 times 5, which is 20. Okay, that uses the angle or the perpendicular bisector theorem. Okay, what is QR? QR is here. Can we just say that our answer is 5n minus 7? No. So let's look for our theorem. Do you see any markings on the diagram? Okay, do you see any markings on the diagram? Okay, what do those markings mean? Congruent segments, so what is S? So SQ is a bisector, so S is a midpoint. So QS has to be a bisector, but it's a special type of bisector. Now what type of bisector is it? Because of a 90-degree angle. So we can use a perpendicular bisector theorem. Any point along the bisector, in this case Q, if we connect it down to the endpoints, these two lengths have to be what? Say we have a C word for that in geometry. Congruent. So we can put them equal to each other. 3n minus 1 has to be congruent or equal to 5n minus 7. Okay, would you solve for n, please, and stand up when you have n? Solve for n, please, and stand up when you have n. Brian, names are filling here for reference. Okay. Inverse operations to get n by itself. Good. Where was that? Where was that? This is, you need to add 1 over, so that would be -6. So add 1 on both sides, not be -6. After school, not right now, get your hands together. There's a smaller one. How do you move that 3n? So subtract 3n on both sides. Do you haven't already, find what QR is. So plug that back in if you haven't already. Okay, now get your constants together. Okay, n by itself. No, we're removing it. They're already together. Remember the constants, the ones without n's. Are those inverses? That looks the same to me. There you go. So 7 equals 2n, because you didn't actually subtract that. I'm sorry, it's not 7 is 6, because then 1 plus 7 is 6. How do you get rid of the 2? So what's 6 divided by 2? No, 6 divided by 2 is 3 equals, n. I'll plug it in. Find QR, take that 3 and plug it in. Okay. I should have n equals 3. Okay, who can tell me the measurement of QR if n is 3? Because you do 5 times 3 is 15 minus 7 equals 8. So the measurement of QR is 8. Okay? We're going to skip most of the last page except for the bottom two problems using the angle bisector. Okay. Length of RM. RM is right here. How do we know that NR in the middle is actually an angle bisector? Yeah, the range through the middle, NR, N is in Nancy to R. How do we know that that's actually an angle bisector? Do we have congruent angles? Are there markings right there that show these angles are congruent? They are congruent. See that little arc and that little arc? That means they're congruent. If they both have a little arc and a little arc, that means they're congruent. So it has to be an angle bisector through the middle. So we use the angle bisector theorem, which says any point along this angle bisector is equidistant. So that distance to this distance are congruent. But we have a point there for that point R. So this distance to this distance perpendicular to both sides have to be what? Congruent. So do we know this length, or at least a marking for it? Instead of an x, do we know a marking for this length? Okay, so if they're congruent, can't we just set them equal to each other? If they're congruent, we can set them equal to each other. Variable what's in the air, what x is? Set them with x. Solve it, please. How many would you get? 5. Good. You minus 2, x, you have 5x divided by 5. X equals 5. But that's not your answer. Hold on, what do we do with the 5? Good. Plug it in. Technically, you can plug it into either one because they're congruent, right? But RM is what I asked for, so let's plug it into 7 times 5 gives you how long? Good. The measure of AB is 35. Whoa, why did I do AB? There's not anything exactly. So, thank you. Measure of RM, better, Simpson? Thanks for catching that. Okay, last one. What is the length of FB? Before you just go and say that those have to be set equal to each other, you have to verify that you can actually use the theorem. Do we in fact have an angle bisector? How do we know it's an angle bisector? 2 marks showing they're congruent. So then this length has to be what to this length? Equal. As long as they come at a perpendicular angle. Set them equal to each other. Solve for x and stand up when you know the length of FB. Stand up when you know the length of FB. Okay. What's FB? That's x, but what's FB? Here's FB. Good. Here's FB. Good. Good. Page 21. You get x equals root of x. 3 or something like that. For our assignment tonight, we'll be getting a second version of the book, the volume 2. So some of those are two different page numbers. Start on page 531. Would you write this down, please? Page 531. Put in numbers 2 through 10. As you can see, these aren't very difficult, as long as you know the theorem you're allowed to use. And then page 538, 2 through 20 even. The first one is off, the second page is even. Okay, I'm going to take the back two grade books out to the hallway first to get your second volume of the textbook. Well, they're in the volume of the textbook. The front treatments, if you can be putting your calculators away, please. When we're in the hallway, please be quiet. You guys can put your desks back here. So you've got three groups. Come join me in the hallway so we get your textbook. When you get your books, you should be writing your name and class grade in the inside cover. The front groups can come grab the books. There are 2 time sheets, you only have to sign one.